Hey guys, welcome to the next video on Python tutorial for beginners. In this video, I'm going to show you what are decorators in Python, and also I'm going to show you how to use decorators in Python. But before starting with this video, I will suggest you to watch the last two videos in which I have talked about the basics of functional programming in Python. So let's get started with the decorators. So first of all, what are decorators? So decorators wraps a function and modify its behavior in one way or the another without changing the source code of the actual function. So let's see in practice how to declare and use decorators. So first of all, what I'm going to do is I'm going to define a very simple method and I'm going to name it as say hello, for example, which doesn't take any argument and it just prints hello world, let's say. Now let's say I want to decorate this function say hello and I want to print some kind of string before and after the printing of hello world without changing the code of the function. So here we can declare the decorators. So I'm going to declare a decorator function for this and I'm going to name it as decorator underscore func, and this decorator function is going to take one argument and this argument will be a function. Now we have seen in the last video that we can return a function from a function or we can pass the function as an argument of another function. So inside this function, I'm going to declare one more function and I'm going to name it as wrapper function, which takes no argument. And inside this wrapper function, what I want to do is I want to call a function which is passed as an argument of the decorator function. And then at last, I just want to return this function. So I'm going to just call return and I'm going to return the wrapper function without the parentheses. So in the case of closures, we have seen that we can return the inner function without the parentheses and that makes them the closures. Now let's say we are going to pass this say hello function as an argument of this decorator function and this function will be called here. So in order to print something before and after this string hello world, we can print something here also. So here we can just write, let's say we want to print x and we want to print this x 20 times, let's say. So we can just write this kind of notation and after the execution of function, I want to print, let's say, y 20 times. So this is the simplest form of decorator, which takes function as an argument. Now in order to call this say hello function with the decorator, I'm going to declare one variable and I'm going to name it as hello, and then I'm going to call the decorator function, and I told you that this decorator function takes the function as an argument, so we can pass the say hello function as an argument to this decorator function, which will be passed here and it will be called here. Now in the last video, in case of closures, we have seen that because this decorator function is returning the inner function, that means this variable will contain the inner function. So we can call this hello with these parentheses, and because this wrapper function doesn't take any argument, so we can call it like this. And let's run the code and let's see what happens. So when we run the code, you can see before the hello world string, we have printed x 20 times and after the hello world, we have printed y 20 times. So this is a simple form of decorator and this is how you can use decorators in Python. But Python also provides the simple way of declaring this kind of notation. So instead of using this line of code, I'm going to comment this line of code and also this line of code, because instead of doing this, you can use this kind of notation. So just above your function in which you want to apply the decorator, you use @ symbol and then the name of the decorator which you want to apply to the function. And this notation above the function is equivalent to this kind of notation. And now we can directly use this function say hello without the use of these two lines of code. So let me run the code once again and let's see what happens. And the result is the same. So this is how the decorator works. So let's go through the definition once again. So decorators wraps the function and modify its behavior in one way or another without changing the actual code of the function. So this decorator have changed the behavior of this function without even changing the actual code of this function. Now one question which may arise here is, can we use more than one decorator with the same function? So let's try to declare two decorator functions. So we are going to declare two decorator functions, and this decorator function I'm going to name it as decorator X, and the second function I'm going to name it as decorator Y. So the first decorator function is going to decorate your function with the X value, and the second decorator is going to decorate your function with the value Y. So we are going to replace this by Y. Now here above your function you can use the decorator X, and then also you can use the decorator Y above it. So I'm going to just write @decorator Y, and this notation is perfectly fine. So you can use one or more decorators with a single function. So let me run the code and let's see what happens. So I'm going to run this code and you can see what happens. So first of all, the Y decorator has wrapped the function with Y's, and then after that comes the X decorator which have decorated the function with X values, and then your actual string is printed which is hello world. Now one thing to note here is the order of the decorator in which they are used. So now we will try to just exchange the places of the decorator X and Y. And now let's run the code and let's see what happens. So before it was printing Y first and then the X when this decorator was used at the top, and then the X decorator was used, and now when we run the code, the opposite of that will happen. Now if you want to see the equivalent notation of this using decorators, so I'm going to just comment these decorators from here, and let's try to use this kind of notation with our decorators. So I'm going to just uncomment this code, and this time what I'm going to do is I'm going to use this decorator X with the say hello, and I'm going to enclose this notation inside the decorator Y. So I can use this kind of notation which is equivalent to this kind of notation also. So I'm going to run the code, and you can see because decorator Y is the outermost decorator here, it's going to just print the value of Y, and then we have the decorator X which is going to print the value of X, and then our actual string. If we exchange the places of decorator X and decorator Y, then the order of the printing will also change. So now this was the very basic decorator example. So let me remove this example and let me give you one more example. So instead of using this function, let me give you one more example. So I'm going to declare a function called divide, which is going to take two arguments, let's say X and Y, and what it's going to do is it's going to return the value of the division of X divided by Y. And let me remove these decorators from here. So in the last say hello example, our say hello function was not taking any argument, and now we are giving our divide function two arguments. That means we need to change the wrapper function here also. So I'm going to name my decorator as decorator divide, which takes a function, and I'm going to change the wrapper function, and now this wrapper function is going to take two values, which is the value of x and y. You can also write a and b, it doesn't matter, it just takes two values. And instead of this kind of notation, let me print the values of a and b first of all. So inside this print function, I'm going to just write divide, and then we are going to pass the value of a, comma, and comma b. So we are going to print the value of a and b, and then we are going to check if the value of b is 0 or not. So I'm going to just say if b is equal to 0, then we are going to print the message that division with 0 is not allowed, and also we are going to return immediately from this function. Otherwise, if the value of b is not equal to 0, then we are going to return the division of a by b. So once again, without changing the actual function, which is divide, we have changed the behavior of this function, which is divide, using this decorator function. And the last thing which we need to do here is to call our decorator function above our normal divide function. And now I can use this divide function normally. So I am going to just use this divide function inside the print, and I'm going to pass two values here. Let's say 15 and 5, and let's run the code, and it's going to print first of all this line, which is printed using this statement which says divide a and b, which is divide 15 and 5. And then because the value of b is not equal to 0, that means this value is returned with the result 3, which is the division of 15 by 5. Now let's change the value of b, and we are going to just give 0 as the value of b or y here, and I'm going to run the program once again, and now you can see that this statement is printed which says division with 0 is not allowed. And because this function is not returning anything, or you can return a 0 from here, it doesn't matter, and I'm going to run the code, it prints 0 here. So this is how you can use decorators with the function which takes some arguments and return some values. Now let me give you one more real world example which we can use with decorators. So instead of our divide function now, let's say what I want to do is I want to declare a function. I'm going to just name it as myfunc, which takes one argument, a number. So this will be a number, and then this function calculates the sum of the number from 1 to the number which we provide here. So let's say we provide 10 here. So this function is going to give us the sum of the first 10 numbers. And now I'm going to declare a variable called sum, which I initialize it with 0. And in the next line, I'm going to use for I in some range. And this range will be the number which is provided plus 1. Because range starts from 0 and not from 1, that's why I'm adding 1 here in the range. If I want to calculate the sum of first 10 numbers, let's say, and if I provide 10 here, then range will give you until 9. That's why I'm adding 1 here. And then inside this for loop, I'm going to just do sum plus equals I. And at last, I'm going to just return the value of the sum. Now till now, we have seen how to create decorator functions for the functions which takes no argument, or for the function which takes some argument, and we want to use these argument inside the wrapper function. But at times you need to write a decorator function which will be a generic decorator function, which means the decorator function which I'm going to create here will be used with not only this function but the other function which can take this argument or multiple number of argument or no argument. So let's see how we can write a generic decorator function. So let's say I want to measure the timing of this function, how much time this function takes in order to execute this code. And timings we can measure with any function. So it doesn't matter that we need to use this function to calculate the timing. You can also use the decorator function, which I'm going to create with the other functions also to measure the timing of those functions. So because it's a timing decorator, so I'm going to name it as timing, and it takes once again the function as an argument. And because we don't know which argument the function is going to take, right now this function takes one argument, but it doesn't matter. You need to measure the time of the function which takes one argument or two argument or three argument or no argument. So that's why in that case we can use this kind of notation, asterisk args here, and then comma, double asterisk kw args here. And these two arguments makes your wrapper function independent of the number of argument which will be provided with this function. And in order to calculate the timing of the function, we need to import a module. So let's import a module. So I'm going to just write from time import time. So there is an inbuilt time function which we can use to get the time. And now under this wrapper, what I'm going to do is I'm going to just declare a variable called start, and I'm going to save the value of current time here. So whenever you call this time with the parenthesis, it's going to give you the current time. Now in the next line, what I want to do is I want to just create a new variable which I will call it as result, and I am going to assign the result of this function. So let's call this function with the variables which we have provided into the wrapper function. So because we don't know which argument comes with this function, so we are going to just pass these argument as it is into the function argument which is passed as an argument of your decorator. Let's provide the indent here, so this will be satisfied. And then in the next line, we are going to just print the time elapsed. So I'm going to just say elapsed time and then this curly bracket, and you already know we can call a format method on the string, and here as an argument we just want to give the result of the start time and the end time. So let's declare the end time also. After the function execution is completed, we are going to measure the current time once again, and then we are going to just say end time, which is stored in the end variable, minus the start time, and it's going to give us the time elapsed in the execution of this function. And at last, because this function or the other function can also return some value, at last we are going to return the result which we have calculated. So I'm going to just write return this result. So this is the generic timing function which you can use with any function whichever you like. So I'm going to just decorate my function using the timing decorator, and then I'm going to call this my function inside the print method. So print my function, and let's say I want to calculate the sum of first 20,000 values, and I'm going to run the code, and here in the result you will see 0.0 in the elapsed time, because this value is very small and elapsed time is approximately equal to 0 for the smaller values, because we are just iterating over the smaller value, but the sum is the exact sum. So let's increase this value by 2 zeros, and let's also print the value of start time and end time here. So I'm going to just print the value of the end time and the start time, so we know that what is the starting time and what is the ending time. And I'm going to run the program once again, and now you will be able to see that this is the starting time and this is the ending time, and you will be able to see some time elapsed in the execution of this function. And when I increase 1 0 here, so you will be able to see 2 seconds is taken now for the calculation of the sum of this number. So you can use this timing decorator in order to calculate the time of execution of any other function other than this also. So this is how you can use decorators in Python. I hope you've enjoyed this video, and I will see you in the next video.